Welcome back to Understanding Human Anatomy and part 4 of our discussion of the mediastinum. When I left off last video, we had added in the aorta and pulmonary trunk and ligamentum arteriosum to our diagram. I want to talk next about the vagus nerve. And we're going to start with the left vagus. And the left vagus, the 10th cranial nerve, descends through the neck and it runs along with the common carotid artery and the internal jugular vein, and I haven't got the veins drawn in yet. And as the left vagus comes down, it crosses the arch of the aorta, and then it gives off a branch that passes deep to the ligamentum arteriosum and deep to the arch of the aorta, and comes over to the trachea, and then ascends on the lateral surface of the trachea. This branch of the vagus is the left recurrent laryngeal nerve. The remainder of the vagus then passes posteriorly to get to the surface of the esophagus, and then it forms a plexus on the anterior surface of the esophagus. And this plexus is the anterior vagal plexus. And then the vagus comes down and enters the abdomen on the esophagus, passing through the opening for the esophagus at the level of T10. The recurrent laryngeal nerve is a very important nerve because it innervates most of the muscles of the larynx. And without a functioning recurrent laryngeal nerve, the voice box would close and you would have a very difficult, if not impossible, time breathing. The right vagus comes along with the right common carotid artery into the thorax through a thoracic inlet. It crosses over the subclavian vein, and then the right vagus goes over to the esophagus to form a plexus similar to the one on the anterior surface, this one on the posterior surface, posterior vagal plexus. But the right vagus also gives off a recurrent branch, a recurrent laryngeal nerve. And on the right side, the nerve loops underneath subclavian artery and again goes to the lateral surface of the trachea and ascends on the trachea up to the larynx. So we have the left and right vagus, the left and right recurrent laryngeal nerves. The left recurrent loops under the ligamentum arteriosum. The right recurrent loops underneath the right subclavian. The left vagus forms the anterior vagal plexus on the esophagus. The right vagus forms the posterior vagal plexus on the esophagus. Now, I want to finish off the discussion of veins. We've talked about the azygous and hemiazygous and accessory hemiazygous, and I've already drawn in the inferior vena cava. What I want to do next is take care of the superior vena cava, and I'm going to start by going with the tributaries. We have an internal jugular vein and a subclavian vein. I'm drawing the ones in on the left side. They unite to form a brachiocephalic vein. On the right side, we also have an internal jugular vein and a subclavian vein, and they unite to form a brachiocephalic vein on the right side. You notice that there is a right and a left brachiocephalic vein, but only one brachiocephalic artery. The two brachiocephalic veins meet and join up, and where they do, we have the superior vena cava. And now that I have the superior vena cava drawn in, I'll complete the azygous by having it connect to the superior vena cava. And again, let me get some labels in here. We have the superior vena cava, we have the superior vena cava, it is here. We have the internal jugular vein, drawing a label to the right one. We have a subclavian vein, here. And we have the same veins, the internal jugular, subclavian. The brachiocephalic vein on the left side is much longer and approximately horizontal. So let me label the left brachiocephalic vein. And I'll draw a line to it here. So, now that we've got the subclavian and internal jugular veins drawn in, I can also finish off drawing the thoracic duct, because the thoracic duct comes in right at this point and joins the subclavian vein. It joins the subclavian vein right where the internal jugular and the subclavian come together, and it fits right into that fork and return the tissue fluid to the blood. On the right side, there's a structure called the right lymph duct, which is much smaller than the thoracic duct. I'll draw a little bit in here like so. The right lymph duct, which is bringing lymph from the right side of the head and neck and the right upper extremity. And again, the inferior vena cava passes through the diaphragm to enter the thorax at the level of T8, at the highest extent of the diaphragm. I have one more very important nerve to add to our diagram, and that is the phrenic nerve. And the phrenic nerve comes down from the neck, and the phrenic nerve enters the thorax on each side by passing between the subclavian artery and vein, and then comes down onto the pericardium. And on the left side, it follows the pericardium. It's on the lateral surface of the pericardium until it gets to the apex of the heart. Then it bends down and runs to the diaphragm, where it branches out and innervates the diaphragm on the left side. The right phrenic also enters between the subclavian artery and vein, and it also goes to the surface of the pericardium. It's a much shorter route down to the diaphragm on the right side because the heart is mostly onto the left, but it does the same thing, follows the pericardium down to the diaphragm and then enters the diaphragm and branches out to supply the diaphragm. Because it is the primary supply to the diaphragm, the phrenic nerve is an extremely important nerve. Without it, our ability to breathe would be greatly compromised. We talked about the mechanism of respiration. And remember that the diaphragm was critical to that. And so if you are unable to use the diaphragm, you have a much more difficult time breathing, moving air in and out of the lungs. So the phrenic nerve is almost a vital nerve. you can actually survive breathing just with intercostal muscles, but you won't be able to do anything. Yeah, you can sit there or lay in bed, but you would not be able to exert yourself in any way, shape, or form. Just would not be able to move enough air in and out of your lungs. So the phrenic nerve, and the phrenic nerve is actually in the superior mediastinum, and then it would be considered in the middle mediastinum since it's running on the surface of the pericardium. Now, you will notice that while I've described structures in the superior mediastinum, the posterior mediastinum, and the middle mediastinum, I haven't mentioned anything in the anterior mediastinum. And there is one significant structure, and how large and significant it is depends on one's age. And that is the thymus gland. And the thymus gland is very large in newborns and in children up to the age of puberty. But the thymus gland undergoes a regression process and is replaced by fat. So when you look at an adult, and especially when you look at an elderly adult, which is what you see in the gross anatomy lab, all you find is a fat pad in the area of the thymus. The thymus gland begins in the superior mediastinum and will extend into the anterior mediastinum. And I'm going to draw an outline of the thymus, and I'm going to draw it as it would be in a youngster. And let me just draw it in like so. I'm not going to color it in because that would block everything. So what I just drew in is approximately what the thymus would look like in a young individual. And I'll stick a label in here. The thymus does secrete hormones known as thymosins, and it is necessary for the proper development of T cells of the immune system, a type of lymphocyte. And if the thymus is absent in a child, the immune system fails to develop. And it's the one that was made famous in an old movie called The Boy in the Bubble. The individual has no defenses. In adults, its function has not been demonstrated. In animals that have received radiation that destroys their immune and bone marrow system, if they're given a bone marrow transplant, they need an active thymus to redevelop the immune system. But nothing like that has been seen or modeled in the human. So the thymus or thymus gland, a very important structure in the very young, but it undergoes a regression called thymic involution, such that in the adult it is about 90% fat. And in an elderly individual it would be even more fat. That concludes our discussion of the mediastinum. Thank you for your attention.